Innovations and Challenges of Plant-Based Protein Products by Roman Buckow. Just a brief introduction of our speaker. Roman is the Chief Technology Officer of OLG Foods, an Australian startup that is leading technological innovations for the creation of next generation of plant-based meat and dairy products. He's also an adjunct professor of food engineering at the University of Sydney, and previously Buckow worked as a principal scientist and research manager at Zyro Agriculture and Food, where he focused on the science and commercialization of sustainable food processing solutions for high quality, safe, and nutritious foods and ingredients. Buckow holds a Master in Science and PhD in Food and Bioprocess Engineering from the Berlin University of Technology in Germany, and he has authored over 100 science articles and book chapters, and has been recognized with several awards for his professional achievements. So we are really happy to have you. And before we start, please remember to mute your microphone during the presentation, and if you have any questions through it, you can either write them on the chat so that you do not forget them. And at the end, you can ask them directly to our speaker, or you can also read them. Sorry, I can also read them aloud for you. And well, without any more to say, thank you again, Roman, for being here with us. Welcome. And it's a really nice pleasure to have you as speaker. So go ahead, your audience.
Thank you very much, Viri, and good afternoon, I guess, most of you. It's morning time here in Sydney. Thanks for having me, thanks for the introduction, Viri. Today, I want to talk a little bit about my work and journey over the last 3 to 4 years. As I moved or joined University of Sydney and became the CTO of this startup called OLG Foods. I will briefly introduce OLG Foods in a second, but before I do so, I'll go ahead and talk a little bit about the background and why I'm motivated to work in this area, which is plant proteins. Let's see whether the presentation is working. Hope it is. So I guess we all hear and we know and we understand the impact of animal agriculture on our planet, and that urgent action is required to achieve the net zero emission target by 2050. So I won't dwell really on some of those shocking numbers here shown on this slide, but just a reminder, animal agriculture in particular has major impact on the planet. It uses a lot of water, particularly in times of drought. And here in Australia, we're just bound to have another drought. It's really, really difficult. And it also causes deforestation, and not even touching on animal cruelty and other wonderful things that are attached with, animal agriculture. So alternative proteins, have been considered to disrupt the, animal agriculture in the future. And here's just a few, few graphs, particularly from the Good Food Institute, how much has been invested into alternative proteins over the last decade or so. And on the top left-hand chart, you do see that there's been considerable investments, but for the last 4 and 5 years, it's been massively ramping up. It peaked about 2 years ago. It's still quite substantial in 2022 and 2023. We don't have the numbers yet, but it's probably around the same.
I'm sorry, Roman, I'm sorry. We're not watching your presentation. I don't know what happened. You stopped sharing the screen. Sorry about that.
I had some issues here. My computer did play up.
No worries.
I'm very sorry. So you didn't see the whole thing, or did it just stop?
It just stopped. Yeah. No, I mean, since you started, we couldn't see it.
Yeah, look, I'm very sorry.
No worries. There it is. There it goes. Yeah. Thank you.
sorry, well, maybe then I'll go back one slide. So this was a slide where I was talking about the impact of animal agriculture on our planet. Apologies. Yeah, so unfortunately, I should not have dialed in with my iPad because it started to switch around the presentation between my two devices. And so the iPad is now off. So hopefully there won't be any further disruptions. Yes, so back to the investment into alternative proteins, top left-hand side, the chart I was just referring to, staggering investments up to $5 billion a year into alternative proteins. When I talk alternative proteins, it is not just plant-based proteins, it also considers things like fermentation-derived proteins, or cellular agriculture, where you basically cultivate cells that may be animal cells, for example, in fermentation tanks and harvest them and reassemble them later into food products. I was mentioning it's tough times for, I guess, any venture capital, market at the moment because of the, high inflation and, the associated high interest rates. So investments have almost halved worldwide into alternative proteins over the last couple of years. However, it's still quite substantial. And there's still big investments here in the APAC region, Asia Pacific region, and also in South America, for example. I'm not quite sure with Mexico, but I assume it's not as bad as in the US, where venture capital basically has withdrawn big time from this area. Nonetheless, because of these high investments, there have been many new startups formed, and the ones that I depict here, they are mainly focused on APAC. So the biggest plant-based meat company here in Australia is called V2 Food, and I was heavily involved in the setup of it. But you may have heard about Next Generation Foods there in Singapore, or Just Eat. They're also in Singapore. And they are also in the American market with their products. So why has venture capital pulled out of the area? Well, I think it's worth having a look at the consumer as far as you can generalize the consumer. Why the majority of consumers still haven't really switched or changed their diet. Well, for us, there's still a lower awareness about the impact of diet on environment. Because when you asked what consumers would be willing to do about climate change, they talk about things like recycling or energy saving, but changing your diet, or particularly eating less meat or even less dairy, is not really on the plate for most of consumers. Instead, when it comes to food, the main purchasing criteria for consumers in general are often, of course, taste is number one. It has to be tasty, otherwise they won't buy it again. The price has to be good. If it's healthy, then it's good. If it's convenient, it's also good. But environmental sustainability is not really a strong driver at this point in time. So, or in other words, the environmental pull isn't really big right now. And, many consumers really have been disappointed with the taste, and particularly the cost of, meat alternatives, for example. So now briefly introducing my company, All G Foods. All G stands for All Good Foods. Australia loves to abbreviate everything. So we don't say it's all good. We do say here it's All G. And so hence we came up with the name All G Foods. We do have two sort of businesses or two technologies that we are developing. One is what we call next generation dairy, where we use precision fermentation to recreate nature identical dairy proteins and then reassemble them into dairy products. And on the right-hand side is our next generation meat products, which is basically plant-based protein technology, where we use different sources of plant proteins to recreate, animal or meat-like products. And we're in market with about 20 products here in Australia and New Zealand, starting with the burger. And I will, largely talk about our burger development here in this presentation, but we also have chicken nuggets, we have sausages, we have mincemeat, we have schnitzel, arancini, if you know what that is, and almost any product that you can imagine that you can buy in the supermarket, meat product. I mean, we have the plant-based alternative to it. So when I asked to develop this, that was over 3 years ago, we actually started with a branding exercise. And, as a scientist, that's not the first thing that I'm thinking of. But now, after 3 years, I must admit, I have learned a lot about marketing and the importance and the need for marketing and the right way to communicate to the consumers. Because if you do it wrong, no one will buy you or would be interested in your product. So we went into a marketing exercise and we looked at all the brands that are out there in terms of plant-based meat alternatives, like the Beyond Meats and so on. And we felt that they're all quite green and very preachy. They were really the first thing that you think of these brands is it's about sustainability and making a sustainable product that is environmentally more friendly. But as I just talked about, in the consumer's mind, that's not front of their mind. If you're a vegetarian or vegan, then maybe, but otherwise most consumers don't really think of the environmental impact of their diet. Hence, we felt, no, we need to go a different way and we need to be a bit more sexy, really talk about taste and really talk about that we love meat. And here are just a few things, and you can look up our website, which has changed a little bit since, but nonetheless, we really talk, about meat and the taste of meat rather than having a plant alternative that is better for the planet. So the next thing, of course, as a CTO and head of R&D, my task was, okay, how do we recreate meat using plant ingredients only? And the first question you need to ask yourself is really what makes meat taste like meat? And here's just a word cloud of what consumers tend to say or think when you ask them what does meat taste like. And it's quite heterogeneous, basically. So it's not just one thing that they say it's meat flavor and that's it. No, it needs to be textured, it needs to be chewy, juicy, crumbly, soft, dense, bloody sometimes. So a lot of different things, and obviously there's not just one ingredient that can really do that other than meat. Then the next thing I asked AI, that's quite a while ago, by the way, those images, what is a beef burger? What does a beef burger look like? And what does a plant-based burger look like? And this is what an early version of AI, I can't remember which one I used, came up with. And to my surprise, I don't know what you think, but I thought, Jesus, they're really looking identical. So it's a real challenge. If even the artificial intelligence thinks that plant-based meat burgers look exactly like the meat equivalent, then we have a real challenge. So from an R&D perspective, obviously, challenges are around ingredients. How do you create a texture, which is quite heterogeneous, by the way? So it's not just a smooth texture, other than, you have a Frankfurt sausage. Okay, that's slightly different, but nonetheless, if you talk about a burger or a steak, texture and heterogeneous texture is quite important. Apparently, color is very important for consumers, and I'll touch on that a few more times in my presentation. Of course, flavor, nutrition, yes. particularly when you talk about meat as the main protein source for still a lot of people. And then other things, like shelf life and how do you actually make things at scale come to play. So initially, my task was like that I was given by that was a venture capital fund. Create the best burger that is in the market. And despite me asking a lot of questions, in the end, I said, look, if that is the only objective, sure, we can do this. We have the best ingredients. And a very expensive manufacturing line and no other constraints, then you definitely can have a very great plant-based meat burger in the market. However, as we progressed and hired marketing people, every week basically they came up with another claim that they wanted to add to the product, and eventually here's the full list that I've been given. It had to be vegan. Okay, I knew that. It had to be made in Australia, preferably from Australian ingredients only. That was very different, and we couldn't achieve that. It had to have a high protein content to match what real meat offers. It had to be a good source of iron, zinc, and vitamin B12, like meat is. It had to be non-GMO, gluten-free, no artificial stuff. Had to be healthy, and last but not least, it also had to be cheaper and tastier than the market leader. After I had that full list and many iterations, over 100 iterations of our formulation and production process, we eventually launched this product, as you see it on the right-hand side. So it has a lot of claims. It also, I'm not sure if it's shown here, it's also kosher and halal certified. And as a scientist, you never really realize that, but when you go into production, what I learned a lot is about ingredients and how expensive it gets if you need all the certifications, including gluten-free certification. We don't use any gluten or wheat or grain-based products other than the soy. But nonetheless, to get it certified that it's gluten-free, that is very expensive. And standards are very, very different in different countries. So if you're importing ingredients, then the standards are different and they don't necessarily match the standard in your jurisdictions. Obviously, and I will talk a little bit more how we do all the product development in particular and process development. But I'm jumping ahead now and show a little bit of sensory results here because I'm quite proud of those. So as I said, we've been given a task to beat the market leader, and we've had many sensory and consumer trials. This is one of the latest ones. As Impossible finally managed to enter the Australian market and got approval for their product because they use GMO technology, so it had to go through regulatory approval. They became #1 here in Australia, and so we had to benchmark our burger against theirs. And very pleased with those results and wanted to show them because this is still a relatively small consumer trial, but we asked them, about a lot of sensory attributes. And the black line in the middle is the Impossible burger, and the blue line on the outside is our burger. And as you can see, we beat the Impossible burger in almost all but one attributes quite substantially, particularly in the overall liking and juiciness and other things. The only difference is that the internal doneness, as it's called here, so the color of the burger, Impossible still has an edge. And this is actually what they're promoting big time, at least to investors, because they're using this leg hemoglobin that they produce with precision fermentation and add it to their product. So it does have a very nice red color in its raw state, and it changes color upon cooking. And what I learned is consumers really are confused if the color doesn't change the same way as meat color does change. And we had a lot of backlash initially that our burger was too pink and appeared to be uncooked, even though it was, fully cooked, of course. But because we use a different color pigment, it does not change color as fast as hemoglobin does in meat when you cook it. Another question that is always asked is, and possibly you've asked yourself, are plant-based burgers healthier than the meat equivalents? And well, there's no straight answer to this, but I'll have a quick attempt to it. Here's a comparison of the nutritional panels of on the left-hand side is a formulated Wagyu beef burger that you can buy here in Australia. And then you, in comparison, the Impossible Beyond Burger and our burger on the right-hand side. And I think what you might see is that in general, the at least the nutritional panel is quite similar in many ways, other than the ones that I've highlighted in green and red. And to really jump ahead is here. Most of the plant-based burgers tend to be lower in saturated fat, also slightly lower in protein, but higher in dietary fiber and sodium. And some, not ours, but some plant-based burgers also lack the minerals and vitamins that you would expect to find in meat. But we fortify, and Impossible fortify, so you can fortify it and overcome this. So there's many publications now, and we're working on one as well, that basically suggests that that plant-based meat is a healthy alternative to red meat, I must say, not chicken meat, but red meat. And that is mainly because of the lower saturated fat and the higher fiber content, which in general is considered to be good, and that in general we consider the Western diet to be too high in fat, in saturated fat, and too low in dietary fiber. And lastly, just briefly want to touch on it. And I could give a full presentation on the life cycle analysis that we've done. But in a sense, remember we were asked to have a sustainable burger and have to some sort of an environmental claim, and I was very confident that we would have would look good against a meat burger simply because of the ingredients and how they're grown and where they came from. But we had that certified then eventually as well. And without going into too much detail, compared to an Australian grown beef burger, if you switch to our burger, you can reduce your impact on the planet by nearly 60%. That is certified by a company called Earth, who looks at life cycle assessments and things like that. But a scientific publication is coming up soon as well. All right, but I guess most of the people online are actually students or scientists, so I'll briefly want to talk a little bit about the research that we've done. In full disclosure, though, I can't really drill into too much detail because many of the things that we do is proprietary art or secret IP, and I can't share this with you. So I will just touch on a few things that we've been working on and have been disclosing to the public already. So starting with quality and taste. And for plant-based meat, but also for dairy, by the way, it always starts with a high quality protein. Protein is the main ingredient that we use in our products. And so having a high quality protein is vitally important. Here's a beautiful summary table from the Good Food Institute about plant protein sources that are available to us right now. these plants are known to produce a reasonable and high amount of edible protein, but all come with different cost, functionalities, flavors, etc. That makes them sometimes more attractive, but often less attractive actually to be used in meat replica applications. So in the interest of time, I will skip through the details, but simply want to note that the vast majority of plant-based meat alternatives in the market are based on soy or wheat gluten. Increasingly also pea protein, as the price of pea protein is coming down. And the reason for that is simply, I may say, is cost. It's not necessarily because they have the best functionality or a low flavor or a good flavor profile. It's really, in the end, it's the cost that matters the most. And I had to learn the hard way as well. But nonetheless, I think they are very good and interesting candidates. And we basically have tested all these proteins in some formulations. And must say, at the moment, we're back to soy and wheat mainly protein, so gluten protein. In some instances, we use a little bit of sunflower protein or fava bean protein, but just as a very minor ingredient. But nonetheless, I wanted to mention that there are some things that are quite interesting, particularly crops of interest from my opinion is mung bean. It's quite different from all the others. Has a very nice flavor profile as well. Unfortunately, it's not really available in high quantities, and hence the costs are still too high to be used. Also, chickpea protein, very interesting, very nice flavor. And again, now putting my marketing hat on, chickpeas in general are considered a very healthy alternative. So if you say you have a chickpea protein burger, you can market the heck out of it. But nonetheless, we haven't used it really in a commercial product yet, and that is simply because of cost. Other things that are very interesting is, other oil seeds like canola protein, very, very good. And I'm very hopeful that the prices will come down significantly over the next couple of years. So we will see more and more products, I guess, that use canola protein. And also rice protein, very interesting, very mild flavor. Doesn't have a great functionality, but it is quite inexpensive and has a very plain flavor, and hence, gives a good, can be a good filler, let's say. PDCAS is not as good, but as we know nowadays, we formulate, and if you mix different proteins, then your PDCAS score can actually be very high. The other thing I wanted to note on proteins is we see more and more new protein ingredients coming online that use different fractionation processes. In the past, most of the proteins you can buy as bulk ingredients, and that is, protein concentrates or protein isolates, are basically based on the process that have been developed decades ago for soy protein or soy protein isolates, which is a wet extraction process, and using alkaline precipitation, etc., etc. It's it's a very expensive process. It is very harsh on the protein, so most of the protein functionality is actually lost. And it also uses a lot of chemicals, creates a lot of salts, and uses a lot of water. And in the end, you need to, use a lot of energy to dry your protein into a powder again. So it has a lot of disadvantages, but the main advantage is it's established. It's the only process really at the moment that can yield a very high protein content. So meaning if you want a protein isolate, there's no other than using a wet fractionation process. But there's a new wet fractionation process that are a bit more gentle, and don't change the functionality of the protein as much as the normal ones do. They are more expensive, of course, but I've seen very, very good soy proteins, for example, that are quite different now from what we used to have 5 years ago. Another technology is fractionation. So basically, instead of wetting your beans, for example, and then mill them and then fractionate them with membranes, you basically just mill your beans into flour and then use an air classification process. And I think on my next slide, I'll briefly talk about that, to separate the protein and the starch. It's a very cheap process, but unfortunately, the protein content you can achieve is usually just around a 60% protein content, which is enough for many meat applications, but sometimes it's not enough. The other drawback really is, that's on the next slide, is that it still contains some of the pigments and some of the flavors, so makes formulation quite challenging. Some of you might actually also work, and I have been working when I was at CSRO still, on other alternative protein sources from algae and seaweed and duckweed and alfalfa leaves. But I thought there's a very nice publication actually published in Trends in Food Science and Technology that has this graph basically showing that if you need a high protein purity, so meaning in the 70-80% protein content, then anything but legumes or some of the oil plants doesn't really work, because the protein content of the raw material is so low, and you need to have there's so much processing involved to increase protein content to 80%, that in the end the whole process is not sustainable and the end product is super expensive. So unfortunately, I must say I can't quite see seaweed and algae really being an alternative to pulses or some of the oil seeds that are currently cultivated. But there's a lot of science, and if you're in this area, I think there's so much opportunity still to improve extraction processes and to improve functionality of these raw. So in my University of Sydney role, we really now we still have a big project looking at dry fractionation, so air classification, as I call it, where we look at a variety of raw materials. These are mainly legume area, which we mill and then air classify, and we're trying to optimize that separation and fractionation process. But I can't go into too much detail at this point in time, unfortunately, but we do see there's a lot of opportunities to improve and optimize this process and really get to a high protein concentration. Some of the plants really work well, like chickpea, for example. The material is really good to fractionate, and the protein concentrate has a really good functionality and good sensory properties. And on the right hand side, it's just an example of different. We fractionated soy, mung bean, fava bean, chickpea, yellow pea, and we compared all of that with a wet fractionation process. And what you see here in that table is simply protein solubility. And the higher the solubility of the protein, the lower the degree of denaturation, and depending on the application, but generally speaking, the better the functionality of the product. Blue is wet fractionated, green is dry fractionated, and I guess you can tell that the dry fractionated proteins, they have much better solubility and largely maintained the native structure of the proteins. All right. in the interest of time, how are we doing? Yeah, 10 more minutes. Okay, I'll probably need to go a bit faster now. Now, briefly wanted to talk about the two main challenges when you're trying to formulate and create a plant-based meat analog from plant ingredients, and that is mainly around texture and mouthfeel. Simply the question that you need to ask yourself is, how do we convert a largely globular vegetable protein structure into a fibrous, more meat-like structure? So in the middle, you see prolegumin. So it's one of the main proteins in legume proteins, and it's a globular protein. Whilst most of the meat proteins, as we know and as we enjoy, have a fibrous structure. So that is quite difficult to convert the globular into a fiber structure. The other challenge is, how do we basically solidify plant oils with clean chemistry into ingredients that resemble a bit more like animal fats that tend to be solid at room temperature, and hence create quite a different texture in the mouth and as you use them, cook them, etc. And I'm just briefly going to touch on this. So on the protein side of things, we talk about protein texturization. So that is the conversion of globular protein into a more fibrous type structure. There are quite a few technologies that can or claim that they can do this. The ones on the left-hand side, they're really early stage and more lab scale. And at this point in time, super expensive, but interesting. So if you're interested in this area, I would encourage you to think about some of these technologies like electrospinning or freeze alignment technology. But as a company, we concluded, well, this is way too far and too expensive to be considered. Next one is more pilot scale, in my opinion, still 3D printing. There's a few startup companies, including Redefined Meat from Israel, that claims that they have commercialized this technology and they might have a viable business with this. There's also shield set technology from Rival Foods in Holland. But again, we concluded after extensive cost-benefit analysis, this is way too expensive to be used in a product that is sold in the supermarket. So the way to go is either traditional meat processing, which is basically just mixing of proteins and hydrocolloids and oil and water, and then cook it. And then you can get a fine emulsion type product like a sausage, for example. Or you use extrusion technology to structure the proteins in the extruder and get a fiber structure at the end. You can do this with dry extrusion processing, which tends to derive a texturized vegetable protein, or in short TVP. It's more a sponge-like texture, and at the end you have a dry ingredient that you still need to rehydrate before you use it. But this works well, and we probably use this in 90% of our products. The other technology is high moisture extrusion, where you use a much higher moisture content during extrusion, and then you need a long cooling die at the end of the extruder to form a filamentous meat-like texture of your protein. It works really well, and it really assembles. You can create quite interesting textures and very long fibers, as you can see on those pictures. So there's quite a few products in the market already that resemble chicken chunks and other things. We also use it for a couple of our products, but I can't disclose which ones they are. But very interesting, but an expensive technology. Now jumping ahead, I might not have time to go into the details, but we looked extensively at creating texturized vegetable proteins, low moisture extrusion, because we felt it's from a cost basis, works a little bit better for us. We analyzed all our extrudates in many ways, and these days there are so many tools available to do that. And again, I'm jumping ahead, but we also then presented some of this to a sensory panel with just wanting to confirm with what we measure with instruments actually is somewhat reliable and aligned with what the consumer experiences when they put it in the mouth. And long story short is that unfortunately many sensory attributes cannot be accurately characterized by instrumental measurements. So on the PCA plot on the right hand side, only hardness was somewhat correlated. All the other things, including even color, was not correlated with what the consumer's feedback was. So unfortunately, we concluded, well, instead of buying a lot of expensive gear, we still gonna have to use consumer panels on a regular basis. And in fact, we use them on a weekly basis to test our prototypes and test our new formulations and get a rapid feedback. I might skip this video in the interest of time from Klextra to explain how high moisture extrusion works. I guess most of you actually know the technology, and if you don't, I encourage you to check Google or YouTube. There's a very nice one from Klextra, which I have here, but I won't show now in the interest of time, because I also wanted to talk about fats and the importance of fats. You may know fat content in most animal or meat products is fairly high. In a burger, in a very good burger, high-end burger, it's above 20%. We use about 15% in our burger because we try to be a bit more healthy. But you have many other products like bacon, and here's some other small goods that we developed like pepperoni, salami, and so on. Very high in fat content. So if you manage to get your protein work the way you want to work, but you don't pay attention to the fat, then you still can't create a good meat analog. So we invested heavily into this, and we went on a very extensive study over 2 years to basically try to find a way to embed it or entrap our typically liquid fats and flavors into a gel structure. This gel needs to hold up to 30% fat, needs to hold firm and don't melt when you heat it, or not fully melt when you heat it. It needs to be engineered in a way that it works similar when you cook your burger, when you cook your bacon, as shown on the top there. It's very important that you have this sizzling, because the sizzle also, it's not just a visual thing, it's also very important on the flavor creation and the creation of a nice crust. If you don't have sizzle, your product will just go very dry and won't be pleasant to eat. So again, I can't go into too much detail, but we've patented a formulation where we use different gums, and particularly we use konjac. I think I had that on the previous slide. Konjac gum and gelan gum in combination with some other gums to create this gel texture, and embedded our oil there. You possibly see a video on the right hand side that this gel really holds firm when you press it, but it also loses a lot of water when you cook it, so which is important. And it's as I said, we patented it because it was the best combination that there is, and it had some non-obvious things to it, so we felt it's quite innovative, and we use it now in all our products. Likewise, you need to use a binder system because while it's a meat patty tends to hold together by itself because of all the different ingredients. If you use TVP and fats and flavors, they tend not to hold together, so you need to bind them with something. And the binder of choice typically is methylcellulose. It works really well. It's incredibly good at binding these ingredients. And I must say, even though I've read something different online, it's the only gel or binder that I could find if that when you cook it or when you heat it, it actually firms up. It doesn't go into goo and you know, doesn't flow away as most other gels would do if you heat them. Methylcellulose is very different, and hence everybody's using it, and no one really has cracked to get rid of it, other than in a sausage type situation where you have a casing that holds the shape. Color, briefly want to touch on that in the next couple of slides, but also flavor, very important and quite challenging actually to recreate the flavor when you're only allowed to use plant ingredients. We use GC-MS and LC-MS a lot to come up with the right profiles for our different products and then test them with consumers again and again. And it's quite incredible what you can do if you can use a lot of ingredients. And you know, the only thing that I can disclose is that we use quite a lot of amino acids to get the umami flavor and also the browning happening during cooking, and the rest really is some other minor things and grilled flavors that you add to improve you know, the barbecue flavor of most of our products. As an engineer, I really love that scale up challenge, but I don't really have time to talk too much about it. And of course, it's all proprietary, so I can't really go into detail, but it took us a long time to scale up our production to make it efficient so that we don't have any losses, that the burger holds shape, and that it actually all works in the factory. Biggest challenge apparently, or was for us really, that the burgers don't stick to the conveyor belts. That was the biggest challenge to overcome, because we had to completely change our formulation. That we use methylcellulose, for example, it does not only love to bind the ingredients, it also loves to bind to conveyor belts, and hence caused a lot of problems for us. Safe shelf life was also, particularly as you want to go to retail, and you know, if you don't add a preservative, and we use natural preservatives here, cultured dextrose as it's called, that really works well. If otherwise, if you don't have that, then your shelf life is as short as 4 to 5 days, which, you know, is similar to mincemeat or other kind of things. But unfortunately, for some reasons, consumers expect packaged burgers, plant-based burgers in particular, to have at least 10 or 15 days shelf life. So we had to, you know, go through a lot of iterations there as well. So my probably final slide then is around how we go about our product formulations and testing. And here's something that we went into a competition in Singapore called Scale It Up. I think you also have it in America and in Europe. It's sponsored by Cargill, Bühler, and Givaudan, and we entered with that is over a year ago now, with a plant-based salmon fillet. And basically, as you can see here, you always start with a texture development, then try to optimize the particle size, optimize the binder system, fine-tune color, flavor, then try to make it work at scale, and present it to a consumer panel, and get the feedback, and do it all over again. And the more often you do it, the better is your product in the end. In this case, because we entered this challenge and we did not have an awful lot of time, we only had like 10 iterations or so. So it's not perfect, but I'm not sure if you can see the video, but I wanted to show you, because I'm quite proud of it, what we came up with. This one, you know, is a source of omega-3, you know, source of lycopene. It really looks, cuts and tastes like salmon fillets, very fatty as well, which is our binder system that I just talked about. And in an application with some nice, dressings, it is really, really tasty. We briefly commercialized it here in Australia, but the cost is still a bit prohibitive because unfortunately, when you go into a supermarket, whilst you pay a premium, but supermarkets will only take it if you can sell it for, I think on US dollar basis is about $15 per kilogram. And that is quite challenging to achieve when you have all these ingredients, and they're quite a difficult manufacturing process. All right, in the interest of time, I'll skip through regulatory approval. My second last slide then is really something that is a thorn in my eye, and let's talk about costs. And one of the biggest hurdle for consumer adoption, in my opinion, is the cost of plant-based meat and also dairy alternatives, because they are not sure in in Latin America, but here in Australia, on average, I would say they're about twice as expensive as the animal equivalent. And why is that? Here's a slide that you're rarely going to see, and maybe I get criticized for it big time eventually. But I've tried to really explain why that is. Firstly, ingredients, unfortunately, tend to be more expensive than meat ingredients. We also need to remember meat, at least in most countries, and also dairy is highly subsidized. And hence, and if you look at mincemeat, for example, it's really kind of a byproduct from the cow. After you trim off all the premium cuts, everything that's left you may mince, and so that is just a byproduct. So the farmers don't really make a lot of money from the mince or the processors. So it's quite inexpensive. Manufacturing costs tend to be much higher, and that is mainly because it's you have to assemble a lot of different ingredients, and you need to cook them, and you need to form them, and it's not as easy. But I think the main reason why it's more expensive is it's simply the lack of the economy of scale. Meat and dairy processing plants are gigantic, and if you want to go to a plant, we have a dedicated plant-based meat co-manufacturer that we use. They're quite small in comparison, and hence they don't really have that economy of scale, so it's quite expensive. But the biggest issue, in my opinion, is that the retailers, if you have a retail product, they take a big margin on these products. Typically, depending on the country, but 50% is not unusual. That they, from the end price, if you sell for $10, the supermarket takes $5 as a profit margin for them. That is for plant-based alternatives, whilst most retailers, at least I'm sure in America as well, actually, they're happy to not take any margin on mincemeat, for example, or white milk, and that is simply because they use that to lure consumers into the supermarkets. Everybody goes to the supermarket on a regular basis to buy milk and possibly meat, and they try to make it inexpensive and make the consumers go there on a regular basis. So there's a very unfair disadvantage. And lastly, and I just learned that in Germany, they just start to talk about it. Many animal products, particularly meat and dairy products, are exempt from GST, so that's the sales tax, whilst full sales tax apply to the plant alternatives. And that is simply because it's just considered a luxury product. You don't need it to survive, basically. But depending on the country, here in Australia, it's a 10% difference. In Germany, it's 20% difference. That is on top of the price as well. And hence, there's no way with the current system as it is, that you can achieve price parity. So in conclusion, because I'm running out of time, here's some opportunities, I think, for future research. On the consumer side, I think we all can do something to, get better recognition of the impact of diet on climate change, and really to, think about, the price of meat and dairy. Is it fair? Is it good? It's certainly not good for the environment. I mentioned new crops and new crop varieties, new ways of extracting proteins from different varieties. So I think that would be something to look at as well. Rally governments, to announce carbon neutral plans that include a change of the current agriculture systems. And from a science and technology point of view, I think, we're here in Australia, at least, and I'm sure it's the same in the US, getting hammered by the meat industry that, plant-based meat alternatives are not good for you and not healthy, and they're bad for your gut microbiota and so on and so forth. So I think this is obviously just playing with feelings. There's no real scientific evidence. So I think we need more evidence on the impact of plant diet on gut microbiota and the benefits of it. And on new technologies, we're really embracing cell ag here at OLG Foods to produce, using precision fermentation in particular, to produce special ingredients that significantly improve the quality of our products that we can't really achieve with plant ingredients that are currently available. And with that, thank you. And sorry that I went over time quite a bit, actually.
No worries. Thank you, Roman, for your enlightening presentation. And so we just have time for one question, perhaps, if anyone from the audience want to.
I already mentioned I can go 5 minutes over if we have to.
Okay.
But yeah.
Let me actually stop.